Vapotherm is the inventor and market leader in high-flow thermally controlled humidification systems for high-flow nasal cannula therapy. Vapotherm devices are cleared for delivery of breathing gases by nasal cannula at flow rates of up to 8 liters per minute in infants and 40 liters per minute in adults, providing what is known as high-velocity nasal insufflation, or high VNI. The Vapotherm Precision Flow is the only high-flow system designed to deliver high flows and high velocities. Our innovative approach to non-invasive respiratory support offers clinicians a comfortable alternative to treat both hypoxemic and hypercapnic patients normally placed on alternative pressure-based respiratory modalities. Let's take a closer look at the technology that makes this possible. To create medical-grade vapor, water is gravity-fed into the disposable patient circuit, where it is heated into the vapor transfer cartridge. Once the medical-grade vapor is created, it travels through our triple-lumen water-insulated delivery tube to our small-bore, high-velocity nasal cannula. The highly energized gas is now delivered to the upper airway. The small inner diameter of our nasal cannula generates a high-velocity flow that flushes the extrathoracic dead space of expiratory gas between each breath, creating a fresh gas reservoir that facilitates oxygenation and alveolar ventilation. Under normal breathing conditions, approximately 30% of an inspired tidal volume represents anatomical dead space in adults and up to 50% in neonates. At the start of inhalation, this dead space is filled with expiratory gas remaining from the previous exhalation. Without intervention, if a patient in respiratory distress is rapidly breathing in an attempt to flush excess expiratory gas, it is likely that the patient will fatigue and experience respiratory failure. By creating a reservoir of CO2-depleted oxygenated gas in the dead space, we can lower the minute ventilation required to achieve adequate alveolar ventilation and reduce the demand for work from the respiratory musculature. Circuit design is critical to deliver high-velocity flows. Volumetric flow is the volume of gas that passes over a unit of time. The speed at which that volume travels is the velocity. Velocity at a constant volumetric flow varies inversely with the cross-sectional area of a tube. The smaller the cross-section, the higher the velocity, as shown in this fluid model animation. When applying this concept to circuit tubing design, you can see that a small bore system will have a much faster gas transit time when compared to a large bore system, making it less susceptible to cooling and condensation from external environmental conditions. This also applies to the cannula prongs. When the gas is delivered through a small-bore nasal cannula, the velocity and energy of gas entering the nose is much greater than a large-bore cannula design. The small outer diameter also allows for unrestricted expiratory gas egress without generating large amounts of airway pressure. The physiologic impact is that expiratory gas is more efficiently flushed from the anatomical reservoir in the time between breaths due to the turbulent energy created by the high-velocity flows. The graph displayed here shows the calculated velocity difference between a Vapotherm adult cannula and a commercially available large-bore cannula. At a volumetric flow of 40 liters per minute, Vapotherm delivers a velocity almost 6 times that of the large-bore cannula system. For a patient in respiratory failure, time is critical. High VNI has the greatest impact during the exhalation phase of breathing, when it resets a significant portion of the anatomical dead space as a reservoir of fresh CO2-depleted gas for inhalation. As the patient's respiratory rate increases, the time to flush the expiratory gas from the upper airway decreases. For example, an adult patient with a respiratory rate of 20 breaths per minute or above has 1.5 seconds or less of time between inspired breaths. Looking at the patient continuum of care, we can see that as the patient acuity increases, so does the therapy invasiveness. We know that all high-flow nasal cannula devices are great oxygenation tools that helps bridge the gap for patients that have severe hypoxemia issues. High VNI, however, also can have a pronounced ventilatory effect associated with optimal CO2 purge and extend the reach of the nasal cannula in this continuum. In practice, high-velocity nasal insufflation is the application of conditioned breathing gas delivery to support breathing effort. High VNI is a refined application of high-flow nasal cannula that accomplishes several objectives for a reduction of work of breathing, reducing inspiratory resistance, approaching peak inspiratory demands, flushing of dead space, providing mild distending pressure, and increasing metabolic expenditure related to gas conditioning. When applied appropriately, you will be able to reduce the overall acuity of care without sacrificing patient comfort.